let's talk about the integration of the trigonometric functions. So we know how to integrate the standard trigonometric functions, right? So sine of x, its antiderivative is minus cosine of x plus the constant. And the antiderivative of the cosine of x dx is equal to plus sine of x plus the constant, right? Now what I want is I would like to figure out the integration of the combination of these two functions in different powers, okay? For example, let's start with the integration of the cosine cube of x. Okay? So I would like to find the cosine cube of x. Either I need to figure out how to decrease the power of the cosine of cube using the trigonometric identities. Either I need to use the substitution, okay? So let me rewrite this differently so that maybe you will come up with the idea. So I would like to write this. Cosine square of x multiplied to the cosine of x dx. Okay? So let's substitute everything here in this integration with the new variable. Okay? If you decide to substitute everything, so this part, for example, should be the derivative of the new variable. Okay? This part should be, for example, dv. Okay? So our substitutions should be something, so the dv is equal to the cosine of x dx. So what I need to choose as a v? Sine of x. Right? Now I need to substitute everything in this integration with the v. Okay? Everything. So this is equal to integration of cosine square of x multiplied to the dv, right? Now, is it possible to substitute the cosine square of x using the v? So I know that the cosine square of x is equal to 1 minus sine square of x, right? Why? Because sine square of x plus cosine square of x is equal to the 1, right? Why? Huh? From the Pythagorean theorem, right? Because do you remember we defined the trigonometric functions on the unit circle, right? And we said, okay, so sine of x will be the y coordinate of the point, and cosine of x will be the x coordinate of the point, right? And since all the points are on a unit circle, it should satisfy its equation, right? Do you remember the equation of the circle? X coordinate of the point in a square plus y coordinate of the point in a square should be equal to this radius in a square, right? So since we are on a unit circle, its radius is equal to the 1, right? X coordinate in a square, y coordinate in a square plus x coordinate in a square is equal to the radius in a square, right? So this comes from the equation of the circle and definition of the trigonometric functions on a unit circle, right? Okay, so since the cosine square of x is equal to the 1 minus sine square of x, so what will be 1 minus sine square of x in terms of the v? 1 minus v squared, right? Now, I mean, this integration was difficult. This one is easy, right? So what is the antiderivative of this integration? V minus v cubed over 3 plus some constant, right? If you want, you can resubstitute the v with the sine of x as well. Okay? Now let's make this problem a little bit more difficult. So let's consider another example where I need to integrate sine in the power of 5 of x multiplied to the cosine square of x dx. Okay? Here again, I need to use the substitution rule. Okay? So I know now that if I have some trigonometric function, sine square of x or the cosine square of x, I can transform them, right? So if I need the sine square from the cosine square, it is easy. If I need the cosine square from the sine square, it's also easy, right? Yes? So here, I need the even powers, right? But it appears I need one odd power as well, okay? So could you please tell me how to make the substitution here? How I need to write? Okay, so I will rewrite this and you will tell me. So sine square of x multiplied to the cosine square of x multiplied to the sine of x dx. Okay? Now, could you please tell me what is the substitution? Okay, 4. So cosine of x should be the new variable, right? And what is the derivative of the cosine? Is minus sine of x dx, right? So this term here is minus du, right? Now I need to substitute everything cosine in the square and sine in the power of 4 with the u, right? So if the u is equal to the cosine of x, what will be the cosine square of x? Is u squared, right? So, and I need to also substitute sine in the power of x also with the u, right? So the idea is I would like to write this as the sine square of x in the square, right? And I can write down the sine square of x as 1 minus cosine square of x in the square. What is this in terms of the u? 1 minus u squared in the square, right? Could you please open all the brackets? You will have 1 minus 2u squared plus u in the power of 4, right? Now let's substitute everything in this integration with the u, okay? So this integration becomes integration of 1 minus 2u squared plus u in the power of 4, because sine in the power of 4 is this, right? Multiplied to the cosine square of x is u in the square, and sine of x multiplied to the dx is minus du. Okay? Is it possible to integrate this? Easily, right? So everything is the polynomial. You can integrate this separately. So let me multiply the minus u squared to all the terms in this brackets, and I will have 2 u in the power of 4 minus u in the power of square minus u in the power of 6 du. I multiply every single term in this brackets to the minus u squared. Okay? What is the integration of the 2u for? Is 2u in the power of 5 over 5, right? Minus, what is integration of the u squared? U in the power of 3 over 3. And integration of the u in the power of 6 is u in the power of 7 over 7 plus the constant. Okay? Then if you want, you can resubstitute the u with the cosine of x. Okay. Okay, we'll figure out that if I have if I have the trigonometric function under the integration, right? And if for at least one of them the power is odd, right? Then I can say one function as the substitution, right? And the others I'm going to substitute, right? So basically, if I have the multiplication of the two functions or even the single function, and if the power is odd, then I'm going to rewrite this as, so basically, let me write this. So integration of the sine of x in the power of, so let's say some odd power, okay? So how I can write down the odd power? Do you understand the odd number? What is the odd number? Okay, 2n minus 1, okay? Or 2n plus 1, let's say, okay? So this 2n plus 1 is always odd, right? If you choose the n some integer, this will be always odd, right? So multiply to the cosine of x in the power of m, where m can be any number, even or odd, it doesn't matter, okay? If you have this combination of the trigonometric functions, if one of the powers is odd, then what is the algorithm in general case? So the idea is to write down the sine of x in the power of 2n, right? Multiply this to the cosine of x in the power of m, multiply it to the sine of x dx. That's the idea, right? Because I know that sine in the power of 2n multiplied to the sine, it gives you sine in the power of 2n plus 1, right? You need to add the powers, okay? Then we need to use the substitution. We need to say, okay, so u will be cosine of x, and du will be minus sine of x dx, right? And what will be the integration after the substitution? So I need to substitute the cosine of x with the u. It will be u in the power of m, right? I need to substitute the sine of x dx with the minus du. It will be minus du. And what is the integration? How I can substitute the sine of x in the power of tn? Let me write it. So sine of x in the power of 2n, right? I can write this as sine square of x in the power of n, right? Because if you power something and power this again, you just need to multiply the powers, right? So sine square of x can be written as 1 minus u square in the power of n, right? So we need to substitute here with 1 minus u square in the power of n, multiply it as a u in the power of m, multiply it as a du, sorry. And this is doable, right? Okay. Do you understand the idea, the general idea? So if you have the multiplication of the two trigonometric functions, if the power of one of them is odd, then you can use this substitution, okay? If you have the vice versa, what if the power of the cosine is odd? What you will do? What will be the substitution? The substitution will be u will be equal to this sine of x, right? And du will be cosine of x dx, okay? The problem is when powers of the both of the functions are even, right? What to do in that case? So for example, let's consider the case where I need to integrate sine square of x dx. So if the power of the trigonometric function is even, not the odd, what to do in this case? You cannot do this anymore, right? Because if you split this as sine x multiplied as a sine x dx, right? Then you will have like a square root. Yes? So we need to decrease the power, right? So we've got this equation. So I know that the sine square of x plus cosine square of x is equal to 1, right? And at the same time, I know that the cosine square of x minus sine square of x is equal to the cosine of tx, right? So if you add both of the equations in the left-hand side, what you will have if you add them? If you add them, what you have in the left-hand side? 2 cosine square of x is equal to 1 plus cosine of tx, right? So that is why cosine square of x is equal to 1 plus cosine of tx divided to the 2, okay? If you subtract the second equation from the first one, what you get? Sine square plus cosine square minus cosine square plus sine square. What you get? 2 sine square of x, right? We need to substitute the second equation from the first one in the right-hand side part as well. So this will be 1 minus cosine of tx, and the sine square of x is equal to 1 minus cosine of tx divided to the 2, okay? If the powers are even, then we need to try to decrease this, okay? Using this formula or using the another one. So I've got the formula of the double angle of the sine, right? Do you remember? It was t multiplied to the sine of x multiplied to the cosine of x, right? Do you remember this one as well? Yes? Okay. So in this case, in our example, what I need to do, I need to write down sine square of x is 1 minus cosine of tx over t dx. Is it possible to integrate this? Yes, easily, right? So I need to write this as the integration of the 1 over t dx minus the integration of the cosine of tx over t dx, right? So what is the integration of the first part? Is 1 over tx, right? And the second part maybe is a little bit like a tricky, but it's doable. So this should be equal to the sine of tx over 4, right? Why this becomes to be equal to the 4? Because of the chain rule, right? So let's assume, so here, the idea of the antiderivative was, I need to figure out the function, so that its derivative will be equal to the cosine of tx over 2, right? So what is the derivative of the sine of tx? Derivative is cosine of tx, right, multiplied to the derivative of its argument with respect to the x, which is 2, right? So derivative of the sine of tx over 4 will be cosine of tx over 2. Right? I'm integrating one by one. Yes, but anyway, what is the derivative of the cosine mx dx? Where m is some constant. So this is 1 over m sine of mx. Right? Why? Because if you take the derivative from the right-hand side part, right, it will be the constant multiplied is the derivative of the sine mx, right? Derivative of the sine mx is cosine of mx multiplied to the derivative of the mx with respect to the x, which is m. It will be cancelled with this m. You will have exactly cosine of mx, right? Okay. So do you understand the general algorithm? So the general algorithm is like this. So if you have the multiplication of the two functions, two trigonometric functions, if the power of one is odd, then use the substitution, okay? If you have the one trigonometric function or multiplication of the two trigonometric functions, and if the powers are even, then try to decrease them, okay? That's the idea.